Hey guys, it's me here again. I'm doing a related rates problem, and I'm going to show you an example of what a typical problem looks like and my typical solution of solving it. So here we have a balloon is rising at a constant speed of 5 feet per second. A boy is cycling along a straight road at a speed of 15 feet per second. When he passes under the balloon, it is 45 feet above him. Now, the question is, how fast is the distance between the boy and the balloon increasing 3 seconds later? First of all, you should be able to recognize that this is a very good question. Let's draw a diagram first. That's the first thing. Don't think about any calculus equations or something. Just focus on the diagram. So the balloon is rising at a speed of 45 feet per second. It's 45 feet above him. Okay, so 3 seconds later, after the boy passes under the balloon will be a total, this is the balloon, of 60 feet, because 45 plus 3 times 5 is 45 plus 15, which is 60. This is the balloon. I'm going to write B for short for balloon, and that's 60 feet. Now, when the boy passes underneath the balloon, he's going at a rate of 15 feet per second. Now, assume this speed is constant because the question didn't state otherwise. So 3 seconds later, he's going to be 45 feet away. This diagram isn't drawn to scale, so don't worry about that. 45 feet. I'm not that good at drawing. Please excuse me. And now, like, this should look familiar to you. This is like Pythagorean theorem, a right triangle triangle. The total distance between the boy and the balloon at this 3 seconds later is 75 feet. Now we have an equation too, where we could use related rates. So let's call this X and let's call this Y for the sake of naming a variable. And let's call this D, capital D, just so you don't get mixed up. So the equation is X squared plus Y squared equals D squared, capital D squared. And with related rates, rates refer to time. So we typically use implicit differentiation with respect to time. Now, if you don't know implicit differentiation, simply refer to your textbook or shoot me an email at BrentWayne11. I keep saying it. Shoot me an email asking me to solve implicit differentiation, and yeah. But here I'm assuming you already know that. So this is the equation, and we have to use implicit differentiation. So I'm going to say differentiation with respect to time. So this goes to 2x dx dt plus 2y dy dt is equal to 2d dd dt. And the question is, how fast is the distance between the boy and the balloon increasing 3 seconds later? So this is what we need to solve, d dt. But we know all the other variables, the values of them. So let's go ahead. So 2x is 45, 2 times 45. Dx dt is 15. Plus 2 times 60. Dy dt is 5. So yeah, 5 because the balloon rises at 5 feet per second. Equals 2 times 75 d dt. Okay, so 150 I'm just solving a 7th grade equation right now. 2 times 40, that's 90. 90 times 15 is 1,350. I do not believe in calculators if it hasn't become obvious to you guys by now. 600. Okay, so you add this up, that's 1950. 1950 divided by 150 is 13. So dd dt is 13 feet per second. That means 3 seconds after the boy goes underneath the balloon, the distance between the boy and the balloon is increasing at a rate of 13 feet per second. And this is how we typically solve a related rates problem. You draw the diagram you need, you find the equation specific to the problem and diagram, and then you differentiate that equation with respect to time using implicit differentiation. That's, I really hope this helps. So now, there you go. I have to jump. I'll see you guys on the other side of the bridge. Catch you next time.